Now see ma, theorem number 3 ma. If points x1, y1, z1 and x2, y2, z2 are ends, or you can call it as exteriors. If x1, y1, z1 and x2, y2, z2 are ends of the diameter of a sphere, then prove that the equation of a sphere is x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 equal to 0. This is your theorem number 3 statement. Once again I am repeating ma. If x1, y1, z1 and x2, y2, z2 are ends or exteriors of the diameter of the sphere, then prove that the equation of the sphere is this one. X minus x1 into x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 equal to 0. Again I said each and every theorem is a formula. Na? This is also one of the formula in the problematic part. Whenever in the statement they give ends of the diameter, what is the sphere equation if they want, there you can use this one as formula. Before that we have to show this result. Again to prove this result, first I want to plot diagram for given data. Let us consider this is your sphere. I mean we have to define this sphere equation only. I want to take here it is center C, capital C, right? Now in the statement they given exteriors or ends of the diameter of the sphere, right? This is basically diameter of the sphere. Now both ends they given, this end and this end they given. Now this end I am denoting with capital A. Its coordinates are what? x1, y1, z1, and this end is what? Capital B. Its coordinates are what? x2, y2, z2. Now we have to define or we have to prove this sphere equation is this one, or you have to find this sphere equation, you must get this result, right? For that again I want to take one arbitrary point P on the above surface or sphere P, x comma y comma z, like previous theorem. I mean like first theorem. Let us take P x comma y comma z is any arbitrary point on the sphere, right? After that let us go through direction ratios of this line AB. First find direction ratios of this line AB. After that let us define direction ratios of this line DB. First I am defining direction ratios of line AB, but before that I want to write this. Let P x comma y comma z be arbitrary point on the sphere and A x1, y1, z1 B x2, y2, z2 are ends of the diameter of this sphere. Ends of the diameter of this sphere. Now define direction ratios of line AB. Direction ratios of line AB are, yes, what are those? X minus x1, y minus y1, z minus z1. I am writing x minus x1, comma y minus y1, comma z minus z1. In the similar way, let us define direction ratios of line BP also. Direction ratios of line BP are x minus x2, y minus y2, z minus z2. But if we can see this diagram, in this diagram, these two lines AP and BP lines are perpendicular to each other, right? It is two-dimensional space. These lines are not looking like perpendicular, but it should be perpendicular because this is two-dimensional space. We are plotting three-dimensional figures on two-dimensional space. That's why it is looking like this. But you have to imagine here AP line and BP line both are what? Perpendicular to each other. Now use perpendicular condition between direction ratios of two lines. Clearly I am writing. But this AP line is perpendicular to BP line, right? You can now use perpendicular condition. Perpendicular condition in terms of direction ratios is what? This into this plus this into this plus this into this equal to 0. That I am writing. X minus x1 into x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 equal to 0. Right. After that, let us define locus of point P. You get sphere equation. But here again we take P point as general point x comma y comma z. Locus means no need to change anything, right? As it is expression. But here I am clearly writing the locus of P is x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 equal to 0. But basically P is a point on the sphere. Locus of this P gives what? Equation of the sphere or not. That means this is equation of the sphere or not. Yes, this is the equation of sphere. That's all. If x1, y1, z1 and x2, y2, z2 are ends of the diameter of the sphere, then the equation of the sphere is what? X minus x1 into x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 equal to 0. This is about your theorem number 3. Yes, now let us see theorem number 4. Prove that the equation of sphere passing through 4 points x1 y1 z1 x2 y2 z2 x3 y3 z3 and x4 y4 z4 is matrix determinant x square plus y square plus z square x y z 1. Next, x1 square plus y1 square plus z1 square x1 y1 z1 1. Next row is x2 square plus y2 square plus z2 square x2 y2 z2 1. Next, x3 square plus y3 square plus z3 square x3 y3 z3 1. And last row is x4 square plus y4 square plus z4 square x4 y4 z4 1. This matrix determinant take as 0, you get one sphere which is passing through these 4 points. Basically, this we have to use as formula whenever 4 points points on the sphere. To define your sphere equation, you can use this one, right? Clearly it is available, right? Now, to prove this result, first of all, I want to take general form of this sphere. I want to take general form of this sphere. Okay? General form of sphere is, you know what is general form of sphere? Already I told you. It is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. This is your general form of this sphere. If you want anywhere, you can take this as a sphere equation, right? But in the statement, what they given now? They want a sphere can passes through these 4 points. Here, if you can go through this sphere equation one, here u, v, w and d are unknowns. Let us eliminate them. You get one new sphere. That is your required sphere. To eliminate or to find u, v, w and d values, they given 4 points. Use them. I mean, in the next step, let us consider that above equation or equation 1 and the same. We taken it as equation number 1. Equation 1 passes through first point x1, y1, z1. Then, if this can passes through this point, it must satisfy this point. I mean, replace x with x1, y with y1, z with z1. Then you get what? x1 square, here I am going to write x1 square plus y1 square plus z1 square plus 2ux1 plus 2vy1 plus 2wz1 plus d is equal to 0. Let us take this as number 2. Next, given that this will passes through this second point, if is better. If equation 1 passes through, take second point, x2, y2, z2, then what do you get? Replace x with x2, y with y2, z with z2. x2 square plus y2 square plus z2 square plus 2ux2 plus 2vy2 plus 2wz2 plus d equal to 0. This is number 3. In the similar way, if equation 1 can passes through third point x3, y3, z3, then we have x3 square plus y3 square plus z3 square plus 2ux3 plus 2vy3 plus 2wz3 plus d equal to 0. Take it number 4 now. Again go for last point now. If equation 1 passes through given fourth point x4, y4, z4, then we have x4 square plus y4 square plus z4 square plus 2ux4 plus 2vy4 plus 2wz4 plus d is equal to 0. This is equation number 5. In the next step, by using equations 2, 3, 4 and 5, let us eliminate 2u, 2v, 2w and d. By using equation 2, 3, 4, 5, eliminate 2u, 2v, 2w and d. By using matrix determinant process. That work I am doing in the next step. Here clearly I am writing. Eliminating 2u, 2v, 2w and d by using equations 2, 3, 4 and 5. 2, 3, 4 and 5 we get, including 1 also, and also equation 1. That means by using, I am writing in the proper order, by using equation 1, equation 2, equation 3, equation 4 and equation 5, let us eliminate 2u, 2v, 2w and d by using matrix determinant process. How can we eliminate ones to be? అది ఎలా ఎలిమినేట్ చేస్తున్నామో ఒకసారి అబ్జర్వ్ చేయండి. Go to the first equation. This is free from u, v, w and d. In the matrix determinant, write this x square plus y square plus z square as it is. X square plus y square plus z square. You can write as it is. Next, what is 2u coefficient here? X. Write here x. And what is 2v coefficient? Y. Write here y. And what is 2w coefficient? Z. And what is d coefficient? 1. This is first one. Like that, go for second equation. Here 2u, 2v, 2w and d. The free area is what? X1 square plus y1 square plus z1 square. And 2u coefficient is what? X1, 2v coefficient y1, 2w coefficient z1 and d coefficient 1. Like that, go for remaining expressions 3, 4 and 5. You get like this. X2 square plus y2 square plus z2 square. Next what? X2 and then y2, z2 and d coefficient is 1 in third equation. Go for fourth equation. Here it is x3 square plus y3 square plus z3 square up to here. Next 2u coefficient is what? X3. Next 2v coefficient y3, 2w coefficient z3 and d coefficient is 1 now. In the similar way, go for last equation. It is x4 plus y4 plus z4. x4 plus y4 plus z4. Next 2u coefficient is x4, 2v coefficient is y4, 2w coefficient is z4 and d coefficient is 1. Now let us take this matrix determinant is equal to 0. I mean, to get your required sphere, let us solve this 5 by 5 matrix determinant. It is very difficult actually. That's why just we have to proceed this one as one theorem only. In the problematic part, don't apply this one. Because the reason is, even 3 by 3 6 matrix determinant calculation is very difficult, but it is 5 by 5. Means you have to reduce it to 4 by 4, after that you reduce it to 3 by 3, then reduce it to 2 by 2, then you get your determinant. That is heavy work. That way, in the problematic part, some other way is there. Whenever they given 4 points on the sphere, how can find the sphere equation? Don't use this one, right? Just go this as what? Theorem only, right? If they give theorem, then only do like this one, but no need to remember formula. But this is what? Sphere which is passing through these given 4 points.